In this program, we will implement a thermostat-based cooling system with automatic fan management using structured text in EcoStruxure Machine Expert HVAC. The purpose of this program is to control a cooling fan connected to a variable speed drive VSD. The fan operation is automatically managed using the fan management function block, which adjusts the fan command and speed based on the cooling demand. First, let's look at the variables used in this program. We start with the fan management function block instance. FB fan management. This function block manages the complete fan control logic, including fan stages, speed control, and VSD commands. Next, we have the fan control signal. UI fan control signal. This variable represents the fan demand signal, which ranges from 0 to 1000. It is used as an input to the fan management block to determine how fast the fan should operate. Then we have the output variables. Xfan run. This is the command signal for fan stage 1, which indicates whether the fan should run. UI fan speed out. This variable represents the fan speed command sent to the variable speed drive. VSD CMD. This is the command signal that enables the variable speed drive. The first step of the program implements a thermostat logic. The temperature measured by the NTC sensor is compared with the set point and differential value. If the temperature rises above the set point plus the differential, the cooling system is activated. This means the cooling command becomes true and the cooling output is enabled. If the temperature falls below the set point, the cooling command is turned off. This hysteresis behavior prevents frequent switching of the cooling system. The next step generates the fan control signal. If cooling is active, the fan demand signal is set to 1000, which represents maximum fan demand. If cooling is not active, the signal is set to 0, meaning the fan should stop. This signal will be processed by the fan management function block. The fan management function block is responsible for managing the fan operation. It receives the control signal and calculates the appropriate fan command and speed output. In this example, the system is configured with one fan stage. USINB stage equals 1. This means the controller manages a single fan. The fan frequency range is also defined. The minimum frequency is set to 200 and the maximum frequency is set to 500. This determines the operating range of the variable speed drive controlling the fan motor. All alarm inputs for the fan stages are currently disabled in this example. Manual control and low noise operation are also disabled, meaning the system runs in automatic mode. The block then calculates the required fan operation and generates 3 outputs. The first output is Xfan run. This signal indicates whether the fan stage should be running. The second output is UI fan speed out. This represents the frequency command sent to the variable speed drive, which controls the fan speed. The third output is XVSD CMD. This signal enables the variable speed drive so that the fan can operate. To summarize how the program operates, the PLC continuously reads the temperature from the NTC sensor. The thermostat logic determines whether the cooling system should be active. When cooling is required, the program generates a fan control signal indicating full fan demand. This signal is then processed by the fan management function block, which calculates the correct fan operation. The function block outputs the fan run command, the fan speed, and the VSD drive command. This allows the system to automatically control the fan speed based on cooling demand. This approach improves energy efficiency, equipment protection, and overall HVAC system performance.